Hello, myself Akash Aswani. I am going to give a lecture on forces acting during machining operation, which is taken from the course Manufacturing Process from Mechanical Engineering and is designed for the third year UG students in mechanical engineering. So forces acting during machining operation. So let us consider a machining operation as that a single point cutting tool is used for machining operation in order to machine a workpiece. So while machining, there are different kinds of forces that generated during machining, and the force from as due to friction, there is a frictional force which is obtained at the chip tool interface. Then there is a shear force which acts along the shear plane. So there are four forces as frictional force at chip tool interface, which is denoted by F, and the normal component to that force, which is denoted by N, and shear force along the shear plane and normal force to the shear plane. So these four forces are generated in the machining operation, and in this machining operation these four actual forces are generated in a dynamic environment, so it is difficult to calculate these four forces. So in order to measure the four forces, we have to resolve each and every force in two components, that is horizontal and vertical. And so we are considering two new forces, that is Fc and Ft, where Fc denotes the algebraic sum of vertically resolved forces, which is also known as cutting force, and Ft as algebraic sum of horizontally resolved forces, which is also known as thrust force. And as we know that with the help of dynamometer we can calculate Fc and Ft, which are acting in perpendicular plane, and from these forces we can find out the other four forces, which are the actual forces. So Merchant force circle is a new concept, and it is a concept which can be used to calculate the various forces, to find out the various actual forces from the measurable forces, and the measurable forces which we have just now shown, that is Fc and Ft. So Merchant suggests a compact and a very easiest way in order to find out or calculate the forces which are actually generating in the machining operation. And we are going to see the Merchant force circle in detail in the next slide. But for that, we need to make a certain assumptions for this theory. So the first assumption is tool edge should be sharp. The tool edge which we are considering is sharp, so that the other components of forces due to friction and vibration are neglected. The work material which we are using must undergo deformation across a thin shear plane. The next is there is a uniform distribution of normal and shear stress on the shear plane. The work material is rigid and perfectly elastic. The shear angle adjusts itself to give minimum work. The friction angle beta remains constant and it is independent of phi. The chip width remains constant. So now let us see the Merchant circle diagram. So initially let us consider a single point cutting tool, and a machining operation is taking place, and you can see the workpiece which is shown by red border. Yellow border is used to represent the chip, and the tool is shown with the black border. And you can see the rake angle which is formed, and also the clearance angle. And now you can see the frictional force, which is denoted by F, and which is along the chip tool interface and a normal component to that force and a resultant R. Next we can see the shear force, which is acting along the shear plane and which is making an angle phi, and a normal component to this shear force, that is Fn. Now we can see the horizontal component, that is Fc, which is also called as the cutting force, and a vertical component, that is Ft, which is known as thrust force, and this is making an angle beta minus alpha with resultant R. And this is the circle. So now we have a merchant circle with radius R and the various forces. So from the merchant force circle we can have the following results. As we can see 3 right angle triangles here, and with the help of the knowledge of the geometry we can understand this formula. So we are relating each and every force with R, and using trigonometrical formulae as well as the geometrical knowledge we can find out various forces in terms of R. And in the red bracket we have highlighted the result which shows the relation of R with other forces. So you can have a look at that, where Fc, Ft, F, N, Fn and Fs, this all the forces are related with R and is shown in the single result. So as we are considering the friction, and whenever the term friction comes, coefficient of friction also comes into picture. So that coefficient of friction is between the chip and tool interface, and it is denoted by tan beta, or we can write it as tan beta. And from the above results which we have just find out, and from the Mohr circle we can find out, or we can form a result for tan beta in terms of Ft and Fc. And we are doing this as we are able to measure this Ft and Fc with the help of dynamometer, as we have discussed earlier. Now we will see the relationship between the horizontal and vertical cutting force from the merchant force circle diagram, and the relationship between horizontal and vertical cutting force and various other forces, so that with the help of the vertical and horizontal cutting force we are able to find out the other forces which are actually present in the machining operation. Now let us take frictional force system into picture, and we will find out friction force and the normal to that friction force. So you can see the left hand side of the slide, and we can observe this, that F can be written as OA, which is also equal to CB and is equal to CG plus GB. And after doing some geometrical modification or geometrical adjustment, we can see F can be written as ED plus GB, and this is just a basic geometry knowledge, and you can understand it as you see the figure. So while considering the triangle ODE, we can find out the formula for ED in terms of FC, and GB can be written as Ft cos alpha considering the triangle GBE, and hence we have developed a new result for F, which can be written in terms of FC and FT. Similarly, N is also written in terms of FC and FT, and that can be calculated from the figure. Now we'll see for the shear force system, where shear force is acting along the shear plane. And here also similarly we can express Fs and Fn as shear force and normal to shear force in terms of Fc and Ft, which are horizontal cutting forces and vertical cutting force. And hence finally we can find out all the results for all the forces which are acting in the scenario. So hence we are able to calculate this all the forces in terms of horizontal and vertical forces, which are measurable forces. So actual forces can be calculated with the help of this merchant circle. Thank you very much.